Hi everybody, today we're going to look at velocity time graphs, carrying on from looking at distance time graphs. So if you can make sure that you've got the date and title written down and you've got a calculator, press pause, and then when you're ready to start, press play again. So the first thing that we're going to have a look at are just a couple of practice questions carrying straight on from where we got to previously with the distance, time, speed and acceleration calculations. So question number 1, a horse galloped across a field in 18 seconds. The displacement was 200 meters. What was the velocity of the horse? And number 2, another horse was walking at 1.9 meters per second. It accelerated to a canter, 5.6 meters per second. If this took 5 seconds, what was the value of the acceleration? So what I'd like you to do is to pause, have a go at answering those questions, showing all of your working, and then press play when you're ready and I'll go through the answers. Okay, so first of all, we're going to have a look at question number 1. That's a sensible place to start. A horse galloped across a field in 18 seconds. So I'm going to highlight 18 seconds there. And I'm going to think to myself, what is that? That is a time. Time equals 18 seconds. The displacement was 200 meters. So they're telling us there that displacement is 200 meters. So displacement equals 200 meters. And then it says, what was the velocity of the horse? Now they're asking for velocity, so we need an equation that is velocity equals, and they've given us displacement and time. So what you have to think is, what equations do we know that link velocity, time and displacement? Well, velocity is the vector for speed and displacement is the vector for distance. So where speed is equal to distance divided by time, remember that vector means has direction. Velocity and speed are related to each other. Time is obviously the same for each of these, so we're going to have time on the bottom. And instead of distance on the top, we're going to have displacement. So velocity is almost like a fancy way of saying speed, but it is speed with a direction. So the displacement we know is 200 meters. The time taken for that was 18 seconds. And so the velocity of the horse, if I tap that into my calculator, is 11.1 meters per second. Question 2 says another horse was walking at 1.9 meters per second. It accelerated to a canter 5.6 meters per second. If this took 5 seconds, what was the value of the acceleration? So there we go, I've highlighted all of the data in the question and I've put a line underneath the command, what it's asking me to do. So it's asking for acceleration, which you need to remember is change in velocity divided by time. Now if we look at the data that we've got, we have an initial speed, or I should say velocity, sorry, speed and velocity are not the same thing. The initial velocity was 1.9 meters per second. That's what the horse was walking at the beginning. The final velocity, the velocity that the horse got up to, was 5.6 meters per second. So the change in velocity is going to be 5.6, so its final velocity, minus 1.9, its initial velocity. And we divide that by the time. And if we look at the question, it took 5 seconds. So we're going to do that divided by 5. Well, in the calculator, if you do 5.6, just do that now, take away 1.9, the change in velocity was 3.7 meters per second, and that took 5 seconds. So 3.7 divided by 5, and that gives us an acceleration 0.74 meters per second squared. And that means 0.74 meters per second faster every second. So every second that went past, the horse increased by 0.74 meters per second. And that's the answer just there. If you weren't sure about those, if you got them wrong, just make sure that you've got the right working written down, and then let me know that you found it difficult. Now we're going to move on to having a look at some velocity time graphs, and there are 4 on the screen at the minute. V stands for velocity, and T is time for each of these. Now I'd like to just have a look at those and see if you can work out kind of what's happening. And then what we're going to do is I'd like you to sketch those in your book, just copy the diagrams, make sure they're labelled A, B, C and D, and then see if you can match each graph to the description on the right hand side. So you've got 4 descriptions and 4 graphs, copy them into your book and match them up. Press pause and then play when you're done for me to go through the answers. So here are the 4 graphs. I've just moved them into the centre so they're a bit neater. So the first graph, what we can see here is that the velocity is staying the same as time increases. And actually we can be a bit more detailed and say that the velocity is 0. So what's happening in this graph? The object is not moving. As time progresses, the velocity is 0, therefore there's no, well, as I said, velocity is speed in a particular direction, so there is no speed, there's no velocity, there's no movement here. At B, we can see that there is a velocity, okay, so we have got a moving object, and as time goes on, we can see that the velocity stays the same. So the label that you would need to match up with that would be an object moving at a constant velocity. The velocity stays the same as time goes on. For C, we can see that as time increases, the velocity increases. So if velocity is increasing as time passes, then what we've got is velocity increasing, and what you can't just see there, that is not showing up very well, I do apologise. It's gone off the screen. So what we've got there is velocity is increasing, therefore we have accelerating. And then finally, for D, we can see that as time goes up, the velocity goes down. So if velocity is going down, what description would we have on here? The description that we would have would be the velocity is decreasing, and that would be decelerating. Or actually, as we said last lesson, we could be more precise and say negative acceleration. Deceleration and negative acceleration being the same thing. On the screen you can see another graph, and this one's slightly more complicated than the ones on the previous slide. This is showing multiple stages of a journey. Now it is another velocity time graph. Before we carry on, I would like you to make sure you've got this copied into your book. So make sure that you pause the video now, copy the diagram and press play when you're ready. We're going to look at each step of the journey and have a think about what is actually happening at that part. So if we look at A, we can see that as time is going up, the velocity is going up. So we've got here a positive gradient. Remember, the gradient is the slope, and if it is going in that direction, it's positive. So a positive gradient, we have acceleration. Accelerating. Okay, and it is, as I said, a positive gradient. The graph is going up. Okay, now for B, if we look at what's going on here, as the time goes by, the velocity stays the same. So we've got an object moving at a constant velocity. The velocity is not changing, it's staying the same. And the graph here is flat. At C, you can see that we've got the graph going down. We've got a negative gradient here. The slope is going downwards. Now, what we can see is that the velocity is decreasing as time goes on. So that is an object that is slowing down or decelerating. And that is a negative gradient or slope. Now remember, we can also say that deceleration is negative acceleration as well. And then finally we've got D, where we have another flat part of the graph, but this time it's flat and at 0 velocity, 0 meters per second. So it is there, we've got it, it's still going at a constant velocity, but the velocity is 0. So we would say that that object is at rest or not moving. And again, the graph here is flat. Make sure you've got all of those labels. So press pause if you need to, and then press play when you're ready. To finish off, we're just going to write a couple of things down. For a velocity time graph, the first thing we're going to say is that the gradient equals the acceleration. Now remember that gradient is change in y divided by change in x. Y divided by x. And on the y-axis we have velocity, and on the x-axis we have time. Remember, y goes up, this is the y, and this is the x at the bottom. Now, we looked at the previous lesson and earlier on in this video that velocity divided by time, or change in velocity divided by time, is equal to acceleration. So the slope of the graph, the gradient, is equal to the acceleration. Now, the next thing we're going to have a little bit of a look at is what the area under the graph would be equal to. Now, if we were to take this part of the graph just here, that's not very neat, let's do that again. I'm not very good at drawing these straight lines. So I'm going to draw this square in just here, this rectangle. It's not square, is it? A rectangle. And we're going to say the area under the graph, okay, at point B. Now, if we were to work out the area of that rectangle, if this is the length of the bottom side, if we call that x, and we call the long side y, the area under, or the area of that rectangle, or the area under the graph at point B, would be the length of x times by the length of y. Now if we look at the graph, we know that y is velocity and x is time. So the area under the graph is equal to velocity times time, because the sides of the rectangle are velocity and time. Now we looked earlier at the fact that velocity is equal to displacement divided by time. If we've got a velocity and we've got time, there is a third bit of that equation, which is distance. And funnily enough, well, I should say displacement. Funnily enough, velocity times time is equal to displacement. So the area under the graph is equal to the displacement, or the distance moved in a certain direction by the object that is moving. So what I'd like you to do is just make sure you've got that written down. As always, if you've got any questions, please send me a message and let me know. And then if you look at your assignment, you've got a couple of just extra things to do after finishing the video. Let me know if you need any help.